and welcome. This video is about testing Gadget Reboots PCB for the Arduino ATTiny85 fuse setter and resetter. The previous video you saw it being assembled, and now I'm going to run through a few tests before applying an Arduino and a display to it. So just simple little tests. We're going to check that the switch mode circuit works, and currently I have ground on pin 3, 5 volts on J2 pin 1, which is effectively pin 24 of the IC, feeding 5 volts to VCC. I'm going to start by looking at the circuit here and showing that we are in fact, while it's in the V-reset low condition, we are generating a 5 volts here, because if we look at the 5 volts coming in, we have 5.01, and if we look at the 5 volts going out on the converter, we have 5.2, so a little bit out. Now I could show you the fact that we are dividing down via this divider from 5.2 to 1.25 volts, but I can't due to the high values here. If I put a multimeter onto this point, I measure about 1.3 volts. I can show you this now instead of the 1.25, 1.35. Now that is exactly the same voltage as my 6.5 digit meter. What also happens is when you touch that point, you can see that it's not the 1.25 we're expecting, it's 1.34, but if you look at the output rises as well. So the meter is affecting that input and giving you errors. So the best thing to do is ignore what's being fed back. If it's right and it is 1.25, when you put it onto there, we should see 5 volts, which we do. And if we remove the reset or the RST enable from there, put it high, you can see it goes up to 12.4 volts, which seems adequate. I haven't looked at the data sheets for the chips to find out if it's okay. My sign's going wonky again, I must put that in a box. Now we can check to see if it's coming out onto the target reset pin, which is pin 5 of this one, so it's that one, and it's not getting there at the moment because the reset hasn't been enabled. Now to see that the voltage is getting to the target reset, we can put the probe in there and we have no voltage. The enable pin on the micro or the Arduino is pin 13 or pin 12 on J2. I'll put that in there, and then when we bring this high, Q3 will turn on and pull low. That will pull the base of Q2 down, and that will turn Q2 on, and there we go, 12 volts onto target. And if I put that one onto the ground, we should now, if I enable it, only get the 5. So quick test there, that's showing that the inverter is the DC-DC converter is running, it's boosting. We've shown that the applying a high and a low on the VRST line changes it from 5 volts to 12 volts, and we've just shown that putting a high on the target reset control line, reset enable, we do get either 5 volts or the 12 volts coming out of here. So the last one to check is this one, and we'll look for VTG enable So that's 7 down from the top. So 1, 2, 3, 4, 5, 6, 7. 7 down. VTG target. This is where we're expecting the 5 volts to come out. VTG target, which comes out on the top one, and this is going to be a low P-type FET. The gate is pulled high, so we want to turn this on, so we have to pull the gate low. So hopefully we'll pull the gate low and we should see 5 volts appearing, and there it does. So that has shown that we do, let's put that link in there to enable it permanently. That has shown we do in fact have the ability to switch to target voltage. And we'll just check that the VTG monitor, the target voltage monitor, is working, and that is in fact pin 8. So that's that one there. And then we have it 1.9 volts, so it's a, it's been divided down from the 5 volts to suit the Arduino ADC. So quite a quick one. It's showing that, that part's working, that part's working as expected, that part's working as expected. The OLED, we'll check when we put the OLED in, and the encoder the same. And we have a power LED, as that's wired straight between the supply and ground. And that's about it for this point. The next stage is to plug in the components, so we'll do that now. Well, here you can see I've connected it via a USB hub. The program, which you can download from Gadget Reboots Github, which I'll put a link down below. I'll have to go and find the link for you. And it's based on various different people or YouTubers who have modified it and tweaked it over time. And so here it is. It's using the display routine, an encoder routine, and a timer. I'm not going to go through and talk through all of it because it's obviously Gadget Reboots software. I'm just going to program it and see what happens. Now, mine comes up as an Arduino Nardo. I'm not sure if that's what it should do. It is quite hard, as it is a strange micro. It's different from the ones I've normally programmed. I did try programming it. I put a blinky sketch on it, and then I went to reprogram it, and it won't reprogram. So I have spent a few hours searching on the interweb, and we'll see what happens here. So it's compiling away. And nothing's happening. I really hate Windows, that when you bring something up, you get too close to the top and it goes, no, you don't want to do that, you want to go full screen. No, I don't want to go full screen. As you can see, it thinks the programmer's not responding, and it goes through all sorts of weird and wonderful comments and all this lot up here, which I don't know. If you're into Arduinos, you might have a clue of what the hell's going on, but they're just compiler warnings. But down here, it's just gobbledygook. It's typical Arduino. Whenever I have a problem with Arduino, I often get an error and it just says no information. And I'm thinking, well, you've told me you've got an error, you're not doing what I asked you to do, but you're not going to give me any help whatsoever. And so here it just says programmer is not responding. Well, there is no programmer, it's the chip. So what do? Well, what I found was, if I can find I had a screwdriver here earlier. The only way I was getting it to work the other night was to wait until it was doing that. And there you go. Now, does that make any sense? Wait until it's flashed a couple of times, hit the reset, and then randomly it will then go, okay, I've reset. Oh look, there's a program coming in, and it programs. So let's just see if it's done that. Just remove power, plug the display in. That's the last thing to test. Not a lot happening. Let's open the serial monitor and see if we're getting any. Alright. Oh, I know what the problem there is. There is a line in the code that if we come down here, there is a line which is waiting for the serial to be connected. So if I remove that, comment it out, and the second attempt at reprogramming it. See, there it goes. Seems to work every time. And now it pops up. Right, extended fuse, FF. Default value 111111 is FF. So what have we got for the high byte? Let's try to hold that still. And for the high byte, OF. Right, we'll just show you that we can disable the reset. E15D FE. When it comes back, we can enable the reset. E100 FE. We can disable it again. E15D FE. And when it comes back, the final one is, we can read what it's set to, E15D FE. So that just gets to show all the functions that Gadget Reboot put into his software function. Well, there you have it. Gadget Reboot's board. ATTiny85. Well, if you like this video, click on the subscribe icon, hit the bell, and I'll catch you on the next one.